Hello students, today we'll be dealing with the topic number 7, that is decoders. So basically till today we have studied what is adders, what are subtractors, what is magnitude comparator. The next topic is decoders. So as you can see, a general structure of a decoder which consists of n data inputs and possible 2 to the power of n outputs and something that is called as enable inputs. So basically a decoder is a multiple input multiple output type of a circuit which converts coded inputs to coded outputs. Coded inputs are nothing but what? For example, if you consider 0 1 or 1 0, this is a coded input. Coded outputs are 1 0 1 1 0 2, whatever in the form of binary is there, that is nothing but a coded here. But if you notice here, general structure of a decoder, here we have n data inputs and possible 2 to the power of n outputs. The meaning is here, for example, if you have two inputs, you will be getting 2 to the power of 2, that is 4 outputs. Similarly, if you have 3 inputs, you will be getting 2 to the power of 3, that is 8 outputs. If you have 4 data inputs, you will be getting 16 outputs. So decoder basically it works on the concept of n inputs and 2 to the power of n outputs. Along with this, we have something called as a special inputs called as the enable inputs. The meaning of enable inputs, or why actually enable inputs are used, means here in order to activate a complete decoder. To activate a complete decoder, we need to on one switch called as enable. So if we give enable inputs, then only our decoder will work, otherwise decoder will not work. So coming to the note here, we have two important points. A decoder is provided with enable inputs to activate the output. To get output, compulsory we need to activate the enable input. Second is, the 2 to the power of n output values are ranging from 0 to 2 to the power of n minus 1. Meaning here, if you have 2 data inputs, you will be getting 4 outputs. The 4 outputs will be ranging from 0 to 3. Similarly, if you have 3 data inputs, you will be getting 2 to the power of 3, that is 8 outputs, ranging from 0 to 7. So similarly, if you have 4 data inputs, you will be getting 16 outputs ranging from 0 to 15. So this is a general structure of a decoder which consists of inputs, multiple outputs along with enable inputs. So coming to the binary decoder here. So basically a decoder which has n bit binary input code and one activated out of 2 to the power of n outputs. So the concept of binary decoder is that you have inputs, as I've told you, you have some of the inputs. Consider now 2 inputs. Consider 2 inputs, you will be getting 4 outputs. You will be getting 4 outputs. In the 4 outputs, all the outputs will not be activated at one time. Based on the input combinations, one input will be activated at one time. I'm going to repeat, all the outputs are not activated at one time in decoder. At one combinations of input, one output will be activated. So this we are going to discuss with the help of two types of decoder called as 2 to 4 decoder. Second is 3 to 8 decoder. So first is 2 to 4 decoder. As we know, the name itself says we have 2 inputs and will be getting 4 outputs, and one enable input is compulsory. So 2 inputs and 4 outputs. As you can see, 2 inputs are A and B, 4 outputs are Y0, Y1, Y2 and Y3. So if you can look at this is a logic diagram of 2 to the power of 2 to 4 decoder, where you have 2 inputs A, B, and you will be getting 4 combinations of output Y0, Y1, Y2 and Y3. Now consider now 2 inputs AB, we will be getting 4 combinations. One is 0 0 combination, 0 1 combination, 1 0 combination and 1 1, as we know the truth table. So first, always input take the value from 0 0. First AND gate, if you notice, we are taking the inputs of AND gate from NOT gate, A bar and B bar. That it means that 0 0. So the output will be what? Y0 is equal to A bar B bar, that is 0 0. Next is what? 0 1. 0 1 is what? We take the input from A bar and we take the input from B. Next is what? 1 0. We take the input from A and we take the input from B bar. Similarly, last is what? Y3 A B. AB is nothing but what? We take the input from A, we take the input from B. So these are the 4 combinations. Along with these 4 combinations, we have another special input that is called as enable, which should be connected to all the AND gates, which is compulsory. If enable input is given, then only our decoder will work, otherwise the decoder will not work. So as you can see, we have got the output Y0, Y1, Y2 and Y3. Means here all the outputs will not be activated at one time. For example, if I give the input 0 0, imagine I give the input 0 0, then y0 will be activated. If I give the input 0 1, y1 will be activated. If I give the input 1 0, y2 will be activated. If I give the input 1 1, y3 will be activated. So all the outputs are not activated at one time. 1 1 will be activated for 1 1 input. We'll see the truth table of this. So coming to this truth table here, as you can see, we have two inputs A, B, and we have four outputs y0, y1, y2 and y3 along with one enable, which is compulsory. So here as you can see the statement here the two inputs are decoded into four outputs. Yes, here two inputs are decoded to four outputs. Each output represents one of the minterms. Each of the output represents one of the minterms. So as you can notice in the truth table, we have first enable 0. Means what? If enable is not given, definitely we are not going to get any of the output. If enable is 1, what happens? Combinations now. Two inputs, four combinations. 0, 0 means what? Y0 will be activated. So put 1 under Y0. Rest all will be 0, 0, 0. Similarly, next combination 0, 1. 0, 1 means what? Y1 will be activated. Rest 3 will be 0. Next 1 0, y2 will be activated, rest 3 will be 0. Activated means 1, deactivated means 0. Last combination 1 1. 1 1 means what? Last. Y3 will be 1, rest 3 will be 0 0 0. So here what happens? If enable is 0, the circuit doesn't work. If enable is 1, only the circuit work. If you want to go to the working of this 2 to 4 line decoder, what happens? The output y0 is 1 when a is equals to 0, b is equal to 0. The output y1 is 1 when a is equal to 0, b is equal to 1. The output y2 is 1 when a is equal to 1, b is equals to 0. And the output y3 is 1 when a is equal to 1 and b is equal to 1. So this is a working of 2 to 4 line decoder. Coming to the next 3 to 8 decoder, which means obviously 3 inputs and 8 outputs. So 3 combinations of input we have taken, and for 3 inputs we will be getting 8 outputs. So first is what? 0 0 0. If you concentrate on first AND gate, we are taking the inputs from A bar, B bar and C bar. Means what here? 0 0 0. I will be getting an output called as Y0. Next is 0 0 1. I will be getting Y1. Next 0 1 0. I will be getting Y2. Next 0 1 1. What is 0 1 1? A bar input. I have taken an input from B, I have taken an input from C. So 0 1 1 is Y3. Next 4. How I am going to represent 4? A is 1, B is B bar, C is C bar. 1 0 0 Y4. Next 1 0 1 Y5. Next after Y5 what happens? 1 1 0. Last is 1 1 1. So here I have got 8 combinations of output. All will not be activated at one time. One output, for example, if input is 0 0 0, Y0 is activated. If input is 0 0 1, Y1 is activated. If input is 0 1 0, Y2 is activated. Similarly, it goes on. If all the inputs are 1 1 1, Y7 will be activated. So I am going to read this statement again. A 3 to 8 line decoder has 3 inputs, as we know, A, B, C, and it has 8 outputs, Y0 to Y7. So based on these 3 inputs, one of the 8 outputs is selected. So the 3 inputs are decoded into 8 outputs. Each output represents one of the minterms. So as you can see here, truth table, no doubt enable is there. Enable should be given here. So first take the combination ABC 0 to 7. First 0 0 0, Y0 activated. Put 1 under Y0. Next 0 0 1. Put 1 under Y1. Next Y2, Y3, Y4, Y6. If all are 1 1 1, Y7 is activated. Which is activated? Only put 1 for that. Rest all will be 0 0 0. So this is the truth table of 3 to 8 decoder. So only you have for syllabus 2 types of decoders. One is 2 to 4 decoder and 3 to 8 decoder. Coming to the next topic, it is one of the subtopic of decoder, that is BCD to 7 segment decoder. Now we came to know what is BCD in the previous slides. In the previous videos, that is BCD is nothing but what? Binary coded decimal, which means 0 to 9. That's it. After 9 it is not valid. So we need to link with 7 segment display. We know something called as 7 segment display. For example, if you notice your wristwatches and all, you will be getting a display how 0 is represented in the form of diagram this. Okay, as you can see here, in the form of 7 segment display, you'll be getting the lights, LED lights in your watches. So a 7 segment display is normally used for displaying any one of the decimal digits 0 to 9. So this is a 7 segments. As you can notice here, we have 7 segments: A, B, C, D, E, F, G. So we have 7 segments. So each segment is represented through one of the digits. For example, digit 0. How 0 is represented? You notice here there are some of the dark lines, there are some of the light lines. Notice now here dark lines. How 0 is represented? A, B, C, D, E, F. This forms a 0, but middle line is not activated here. If middle line is activated, number 8 will be there. Middle line is not activated, so this is normally it is 0. So if you want 0 to be displayed, then segments A, B, C, D, E and F should be activated. Similarly 1, notice here dark line. 1 is nothing but what? Only B, C should be activated. Similarly 2, A, B, G, E, D. 2 will be activated. Next is what? 3. A, B, G, C, D. 3 will be activated. So these are the digits. Similarly 4 here. How 4 is represented? In 7 segments, F, G, B, C. 4 will be getting a number 4. 5. A, F, G, C, D. Concentrate on dark lines. You will be getting a number called as 5 there. Next, similarly 6, similarly 7, similarly 8, similarly only up till 9 we can get. As you can notice, do we get here? We don't get any 10 here. For 10, it will display what? 1, 0. Yes or no? For 10, it will be getting as 1, 0. So for 7 segment display, we'll be getting only up to 9. So as you can notice here, digit 0. This is truth table. A, B, C, D 0, 0, 0, 0. Which all the segments will be activated? For example, you notice here in this slide 0 display. If I want to get a 0, which are the segments activated? A, B, C, D, E, F. So see here A, B, C, D, E, F is activated. G is 0. Similarly 1. If you want to get a 1 digit 1, what I'll be getting? So in A, B, C, D 0, 0, 0, 1. Only B, C will be activated, rest all will be 0. Similarly, we need to continue till 9. I'll be explaining 9th now. 9th is nothing but what? If I want to get a number 9, which are the segments activated? A, B, C, D, F, G. Now notice 9 here. A, B, C, D, F and G. E is not present here. So based on digit activation, which are segments activated, put a truth table. So now I have only 3. How many inputs are there? 4 inputs are there. How many outputs are there? 7 outputs, 7 segments. For each of output, I need to put a K-map here. So put a K-map for each of a output. For A, for B, for C, for D. Again for E, F and G. You will be getting the output. Solve the K-map, you will be getting the output. Based on that output, put a logic diagram for 7 segment display. So this is how 7 segment display works basically. We have 7 segments A, B, C, D, E, F, G, H and we have digits 9. We need to we are going to take digits 9 and we are comparing it with the 7 segments. Which are the segments activated for which digit? Those digits are being taken here. For example, BCD is up till 9 as we know, BCD code, and 7 segments which are activated. Take that in the 7 segment code and for each A, B, C, D, E, F, G, put a K-map. Once you put a K-map, you will be getting a result. Put a logic diagram using that results. So this is the end of a decoders, but majorly you will be getting questions on types of decoders. You need to mention 2 to 4 decoders and 3 to 8 decoders. They may ask this BCD to 7 segment decoder. Thank you. If you have any of the questions, please message to my personal number or call me. Further videos I'll be uploading in the next classes. Thank you.